GATE 2022 question number 16 is, consider the following transition matrices P1 and P2 is this, then which of the following is true? So we need to find Markov chain for P1 has infinitely many stationary distribution or unique stationary distribution. Also P2 we need to check infinitely many stationary distribution or unique stationary distribution. So to find answer of this question, we need this result is, if Markov chain is finite, then these are reducible or irreducible. If reducible, then find solution for pi by using equation pi p equal to pi and summation pi equal to 1. If pi has unique solution, then Markov chain has unique stationary distribution. If pi has infinitely many solution, then this Markov chain has infinitely many stationary distributions. If Markov chain is irreducible, then this divided into two parts, that is aperiodic and periodic. If Markov chain is aperiodic, then this has unique stationary distribution, and periodic, this has infinitely many stationary distribution. So we need to check first for P1. Let for P1 state space S is equal to 0, 1, 2. So we write here 0, 1, 2, 0, 1, 2. To first here check S is finite. So Markov chain for P1 is finite Markov chain because state space is finite. Here finite Markov chain. Then check Markov chain is reducible or irreducible. To find reducible or irreducible, we draw first transition diagram. These states are 0, 1 and 2. So we go from 0 to 0 with probability 1, and 0 to 1 is 0, 0 to 2 is 0. Also we go 1 to 0 with probability 1 by 3, and 1 to 1 with probability 1 by 2, and 1 to 2 with probability 1 by 6, and 2 to 2 with probability 1. We know that Markov chain is irreducible if its all states are communicate with each other, that is, we go from any state to any other state. But here see, 0 state is absorbing state. Sorry, we cannot go from 0 to 1. Also we cannot go from 0 to 2. That's why this Markov chain for P1 is reducible Markov chain. So Markov chain is reducible, then find solution of pi by using pi p equal to pi and summation pi equal to 0. So consider pi p equal to pi. This pi is pi 1, pi 2, pi 3, and p is here 1, 0, 0, 1 by 3, 1 by 2, 1 by 6, 0, 0, 1 equal to pi, which is pi 1, pi 2, pi 3. This implies that this pi into p, which is pi 1 plus 1 by 3 into pi 2, and pi 2 here we multiply 1 by 2 into pi 2, and similarly 1 by 6 into pi 2 plus pi 3, which is equal to here pi p equal to pi. So pi is pi 1, pi 2, pi 3. This implies that here first element of this vector is similar to this. So pi 1 plus 1 by 3 into pi 2, which is equal to pi 1. Second element is this 1 by 2 into pi 2, which is equal to pi 2 here, and third element similar to third, that is 1 by 6 into pi 2 plus pi 3, which is equal to pi 3. Here pi p equal to pi. Also consider summation of pi I, that is pi 1 plus pi 2 plus pi 3, which is equal to 1. Here this first equation implies that pi 2 which is equal to 0. Also second equation implies that pi 2 equal to 0. Third equation also implies that pi 2 equal to 0. And fourth equation is this similar to pi 1 plus pi 2 plus pi 3 which is equal to 0. So we have only two equations, that is pi 2 equal to 0 and pi 1 plus pi 2 plus pi 3 which is equal to 0. So we get two equations, pi 2 which is equal to 0 and pi 1 plus pi 2 plus pi 3 which is equal to 1. Here see, this is a system of linear equation with two equations, this and three variables. Here number of variables is greater than number of variables which is equal to 3, pi 1 comma pi 2 and pi 3 which is greater than number of equations which is equal to 2. So system of linear equation implies pi 1 comma pi 2 comma pi 3 has infinitely many solutions, because here number of equation is less than number of variables. So here check, pi 1 has infinitely many solutions. This implies that P1 has infinitely many stationary distributions here. So we check for P2, this is true, but we need to check P2 has unique stationary distribution or not. For P2 we consider a state space is this 0, 1, 2, and for here S is finite, so this Markov chain is also finite. Then we need to check Markov chain is reducible or irreducible. For that we first draw a transition diagram. Here states are 0, 1 and 2. Here see 0, 1, 2, 0, 1, 2. We go from 0 to 0 with probability 1 by 6 and 0 to 1 with probability 1 by 3, 0 to 2 with probability 1 by 2, and 1 to 0 with probability 1 by 3, 1 to 0 with probability 1 by 4, not 1 by 3, 1 to 1 with probability 0, 1 to 2 with probability 3 by 4, and also we go 2 to 1 with probability 1. Here see, in this Markov chain we go from any state to any other state. Here see, we go from 0 to 1, also we go from 0 to 2. Here see, we go from 1 to 0, also we go from 1 to 2. Here also states 2, we can go from 2 to 1, also we can go from 2 to 1. Here like this, we go from first 2 to 1 and 1 to 0, that is we go from 2 to 0. Here all states 0, 1, 2 are communicate with each other. This implies that this Markov chain is irreducible. Here see, finite Markov chain which is irreducible. Then we need to check this Markov chain is periodic or aperiodic. For aperiodic we check period of state is 1 or not. Here state is Markov chain is irreducible. Then we check period of any one state, then this period for all state are similar. So we check for state 0, that is first we know that for ith state period is GCD of n such that Pii raised to n is greater than 0. Here I equal to 0, that is we consider first state 0 d0, which is equal to GCD of n such that P00 raised to n is greater than 0. Here first check P00 for n equal to 1, 2, 3 up to infinity. Here P000 for one step, here 0 to 0 is 1 by 6, which is greater than 0. Then n's take value 1, and so also take other values. We here d0 equal to, this implies d0 equal to GCD of, here n is 1 comma other natural numbers. We do not need this number because we have 1. This implies that GCD of 1 and other natural number that has P00 raised to n is greater than 0. So GCD of this is 1. This implies that this Markov chain related to P2 is aperiodic. This implies that P2 has here aperiodic, then P2 has unique stationary distribution. So here we first check P1 has infinitely many stationary distribution, but P2 has unique stationary distribution. So C answer is true.